shapes that have how many sides?
3 sides.
3 sides. That's what trigonometry is about. So here we are going to focus on 3-sided shapes. Is that okay? Now, a shape that has 3 sides has how many angles? A shape that has 3 sides has how many angles? 3 angles. Is that not so? Yes, it's going to have 3 angles as well too. So here you are going to be learning also about the angles. You are going to be learning about what? The angles as well. Is that okay? You're going to be learning about the angles as well. All right. So we have like this. And this is a triangle, true or false? How many sides do we have here? 3 sides. Is that not so? So as you're preparing for your professional exam, JAMB, WAEC, and of course, getting general knowledge of this, you want to identify this shape as what? A triangle. What about this? How many sides does this guy have?
3 sides.
3. So what shape is this? A triangle. The only thing is that this particular shape is a special triangle. We call it what?
Right angle triangle.
Right, we call it right angle triangle. Because of the fact that it has a special angle that is what? 90 degrees. Alright. In dealing with triangle, there are 3 major types of triangle. Apart from right angle triangle. Apart from what? Right angle triangle, there are 3 other types of triangle. I'd like us to get to know about them quickly. Are you following? Right angle triangle is a special guy. That is where we are actually going to start from. Going right. But I'd like us to get to know about other types of triangle because we are going to study them also. Types of triangle. Basically, we have the following types. Equilateral triangle. Have you heard of equilateral triangle before? Good. Equilateral triangle. Now this triangle, because we know that each triangle has 3 sides. So this equilateral triangle, like the name goes, all the sides are what? Equal. All the angles are what? Equal. That is what equilateral triangle is all about. Are you following, right? So we could say, or draw something like this. Maybe I label here as angle A, label this as angle B, label this as angle C. Are you following, right? Now, this side will be equal to this side, will be equal to this side. This is a representation of equilateral triangle. Now, look at the symbols used there, the markings. We use the same marking here, here, and here. Is that not so? Good. It's telling you that all 3 sides are what? Equal. So let me ask you, if here is 5 centimeters, what do you expect of this side? What about this? Because this triangle is equilateral, the 3 angles are also what? The 3 angles are also what? So if here is 60 degrees, here will be what? Here will be what? That is the type of triangle called what? Equilateral triangle. Number 2, we have isosceles triangle. Isosceles. Have you heard of isosceles triangle before? Isosceles triangle is a triangle with 2 sides equal. With how many sides equal?
2 sides.
2 sides. So I can have something like this, and then I have a different marking on the 3rd side. Are you following, right? So if I call this angle A, I call this angle B, I call this angle C. Are you following, right? Which sides are equal here? Side AB. Understand something about triangles and lines. A line is made up of how many points? 2 points. 2 points makes up a line. Are you getting me right? Or make up a line rather. 2 points make up a line. So the 2 sides that are equal here are side what and what? Are you following, right? Now, because we use the same marking there, if you look at BC, you agree with me that we use different markings. Is that not so?
Yes, sir.
Therefore, this 3rd side is not equal to the other 2. I hope you're following, right? Now, what should we know about the angle of this guy, isosceles triangle? What should you know about it? 2 angles are equal. Are you following, right? And the 2 angles that are equal, we call them the base angles. We call them what? The base angles. The base angle, you know, the base of anything is the side resting on the ground. Is that not so? Yeah. So here we have the base angles B and angle what? C. The two angles are what? Equal. Is that clear? The base angles are equal. So you want to take note of that. So if I call this angle X degree, this angle at point C will also be what? X degrees. And that will be different from this angle. Okay? I can call this Y. Let me give a symbol to this angle. Let us say that this is angle X degree. Here will also be what? X degree. And here will also be what? Because it is equilateral. Now, you see this guy, this isosceles triangle, there's something I want to tell you about their base angles. Are you following, right? So as you are moving on, we don't have to waste much of our time in case we meet a problem on that. The base angles of an isosceles triangle, we say they are equal. Is that not so? There is a theorem we are going to learn about triangle when we enter the angular concept. Are you following? All the angles of a triangle, if you add them together, is equal to what? 180 degrees. Now, if that is the case, let me just do something quickly here. Are you following, right? Let me do something quickly here. If you go to the isosceles triangle, you will now have that. Don't write this. It's not necessary. Once I am done, I'll show you the formula. The formula I want to give to you is that the base angle, X degree, is equal to 180 minus the apex of vertex angle, are you following, right? Divided by what? 2. So you can copy this by the side. Very important that you take note of that. And how we derive this is simple. If you add up all the angles in this isosceles triangle, you will get y plus x. Is that not so? Equal to 180. X plus x will give you what? So this is y plus 2x equal to what? Now we are looking for x because that is the base angle here, true or false. So if you are looking for x, you have to make x subject of the formula. Therefore, this y will be taken to the right-hand side. So you have 2x is equal to 180 degrees minus what? Y. Now if I'm looking for x, and x is multiplied by 2, what do I do to get my x? Correct. If you divide it by 2, what will be remaining? Which is the x degree we are talking about. Is that not so? The base angle. So it's going to be 180 minus y degree divided by what? This formula applies only to isosceles triangle. If you are to calculate the base angles. Are you following, right? Okay, let us move on to the third. Remember I told you don't need to copy this. It's not absolutely necessary. Just write this formula by the side. Base angle. Let me define where x equal to base what? Angle. Now this will take us to number 3 type of a triangle. We have that which we call scaling triangle. Scaling triangle. Right? This triangle is weird. It's what? It's weird, right? Because none of the side is equal to the other one. None of the sides or are. What's the correct answer?
Sides are.
Correct. So, we're going to have something like this. So, I have something like this. So, I will use this. I'll use this. I'll use this. Are you there, right? Good. So, if I have here as angle A, angle B, angle C. You notice that all 3 sides, I use different markings for them. Is that not so? Which means that the 3 sides are not equal. They are not what? Equal. Okay, you're following, right? Now, if none of the sides is equal to the other, are you following? It therefore means that there is no angle will be equal to the other one. Are you following, right? No angle equal to the other one. So in this case, if I am to label the angles, I label this as x degree, this as what? Y degree. Will I label here as x or y or another thing? So let's say that this is z degree. These are the 3 major types of triangle. If you now move further, we now have that special one, like I said. Are you following, right? Right angle triangle. Right angle triangle is special. It looks like this. You have two perpendicular lines. You have how many perpendicular lines? Two. Perpendicular because they meet at 90 degrees. They meet at what? We have met things like this in physics. Is that not so? Good. Then we have this side. We have this side. This angle is special. That is 90 degrees. Are you following, right? Good. If I give you an angle here, theta, for example, let's use theta around. With this, we can define the opposite, the adjacent, and the hypotenuse. Are you following, right? Of that triangle. And it is only this triangle that has these three special names I mentioned: hypotenuse, opposite, and what? Adjacent. You don't call the sides of this triangle any of those names. You don't do that. Are you following? Except if we can drop perpendicular heights here. If I drop a perpendicular height from here, if I drop a perpendicular height here, one side of it will now become a right angle triangle. The same thing here in isosceles. If you draw a height, down, one side will be a right angle triangle. Are you getting me, right? Good. Now, this side, which appears to be like longer, are you following, right? The longest, facing this 90 degrees, is called the hypotenuse. It's called the what? This side, facing this given angle, is called the what? Opposite. Take note, this angle 90 degree is not given. It's not what? Given. It is a follow-come guy. It is what? A follow-come guy. Good. A follow-come angle. Every right angle triangle must have that 90 degrees. That is what defines a right angle triangle. Are you following, right? Yes, so, no be you the giver. Are you getting me, right? You follow the problem, come. The one that is given in the question is this other angle. You see that the angle is given here, or it is given here. Wherever it is given, out of these two sides, out of these 2 points, wherever that angle is given, the side facing it is the opposite. Are you following, right? Let me assume that the angle is given here. The opposite will now be what? The down. Okay, let's follow up what we have here. So if here is opposite, automatically the down here will become what? Adjacent. So this is special about right angle triangle. I hope you are following, right? Good. Those in the online, you're welcome to connect to the class. I hope you follow up. If you have a question, you can drop. Later, I will respond to it. So please, these are the 3 types of triangle. Now, angles. If you add up all the angles in that triangle, no matter the triangle you're dealing with, are you following, right? If you add up the angles, you are going to get how many degrees we said? 180. That is the theorem of triangle. You actually meet that under geometry. Under what? Geometry. So that when we get to geometry and we are talking about sum of angle in a triangle, you won't get confused. Whether it is isosceles, whether it is equilateral, whether it is scaling, whether it is right angle triangle, if you add up the 3 angles in any of this triangle, you get 180 degrees. Now we are done with this concept. We now want to start step by step. First, to deal with right angle triangle. How do you get the value of the side of a right angle triangle? Please write as a subheading, right angle triangle. Right angle triangle. Right angle triangle. Right angle triangle. I hope we are together, right? Now, in dealing with right angle triangle, what are areas of interest to your examiner? Right angle triangles. What does your examiner want you to know? Number 1, how to calculate the sides of a right angle triangle. Are you getting me? And number 2, how to obtain a given angle. Are you getting me? In a right angle triangle. So we have this diagram. First, let us label this as A. Let us label this as B, and then this as what? C. Now there is something we do whenever we are dealing with triangles. There is something we do whenever we are dealing with triangles. The side facing the angle, we like using the small letter of that alphabet to represent it. Are you following, right? Now this angle is angle A, capital letter A, uppercase A. The side facing it is BC, is that not so? Are you following, right? If you draw a line from here, it can only touch this side. I hope you're aware of that. So I am going to label this as what? A. And then here will be labeled as what? Okay, let me make here C and make here B. Are you following, right? Because I like the hypotenuse to go with C. Automatically leaving us here as what? B. Are you following, right? Good. Now, let me assume that I introduce an angle here, theta. Let me assume that I introduce an angle here, theta. Are you there? Now, we are going to start first with what we call the Pythagoras theorem. Remember, like I said, when analyzing problems on right angle triangle, there are just 2 things the examiner really wants you to know. From that knowledge, you can now extend it to the concept of angles of elevation and what? Depression. Are you following? So there are 2 things your examiner wants you to know about this triangle. 1, how can you find the sides? How can you calculate the sides? Are you getting me, right? Which in physics, for those in the sciences, you need a lot of that. As a matter of fact, in our next class, you're going to see a lot of that. Previous physics class, the inclined plane analysis follows this guy. Are you following, right? And you're going to see more from our next class under vector. Are you following, right? You're going to see more. That is why we have to take this topic in your maths. So your examiner wants you to know how to calculate the sides. Your examiner also wants you to know how to find the angles. Are you getting me, right? Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. Now, I won't allow you to write the grammatical expression for that theorem. I won't allow you to write it, but I will state it. Are you following, right? I will state that theorem, but I won't allow you to write it. You can follow through. When we bring out the mathematical interpretation of that law, it will still make sense to you full time. Are you getting me, right? Now, what does that law state? Pythagoras theorem or law states that the square of the hypotenuse is equal to the sum of the square of the opposite and the what? Adjacent. What does it mean? Simple. If you pick the hypotenuse and you square it, if you pick what? And do what? Square it. The adjacent, you square the opposite, add both of them together. Are you following, right? Very simple and straightforward theorem to understand, true or false. So Pythagoras theorem specially deals with how to calculate the side of a right angle triangle when you know 2 sides. Are you getting me, right? When you know 2 sides and you're required to find the 3rd side, you use Pythagoras theorem. You blast the question and you smile out of the question, hoping to smash your 300 and above. Do you understand that? And hoping to blast your A in your WAEC as well. So, grammatically, we say that this theorem states that the square of the hypotenuse is equal to the sum of the square of the opposite and the adjacent. So you have, let's say, the adjacent, you have the opposite, you square both of them, and you sum. Are you following, right? All right, so C square equal to A square plus B square. This is your Pythagoras theorem. So any day you are sleeping, traveling to one country to go and enjoy yourself, and somebody come and taps you, somebody come and tap you from your sleep. Because I sleep, you are flying first class airplane. that you have been taxed, and they ask you state Pythagoras theorem, please, this is what you should know. You can use X, Y, and Z to represent it also if you want. Are you following, right? Good. So that is that about Pythagoras theorem. You use it to calculate any of the sides. Let us move on, please, to another one. The next thing we are going to do here is to talk about basic trigonometric identity. Basic trig identity. Remember what we are talking about. This concept of right angle triangle, our interest is to be able to find the side. Is that not so? Of the right angle triangle. So we are going to move a bit into basic trig identity because we also use that formula to find side or angle. Are you getting me right? Please write. Basic trig identity. Basic trigonometric identity. Trigonometric identity. Trigonometric identity. Basic trigonometric identity. Basic trigonometric identity. I use the word basic because we shall focus only on sine, cos, and what? Tan. These are the three that form the basis of trigonometry. From there, other ones are being given birth to, like the cosine. Oh no, the cosine is cos, rather, like the cosec, which is inverse of sine. Are you following? The sec, which is inverse of cos, and the cot, which is inverse of tan. But hey, we are not talking that yet. We are not dealing with that yet. We are focusing on the most important thing for now on what we are learning, which is how to calculate the sides of a right angle triangle and possibly the angle. Are you getting me right? We start with sine theta. But before we build this trig identity, there is this rule of thumb, these mnemonics that you are always advised to remember. So, ka, toa. This is the guy that guides us here anytime. Are you following, right? So, ka, toa. This S means sine. This O means what? Opposite. H means what? Hypotenuse. This means what? Cosine. A means what? Adjacent. H still maintains which is hypotenuse. This means what? Tangent. Tan. Are you following? Tan. Abbreviation. O again, opposite, and A, the hypotenuse. Are we ready? So let us bring out the formulas. Let's bring out the formulas that make up the base trig identities. We start with the first one, sine theta. Sine of this angle. Are you following, right? Sine of this angle. So, it's going to be the opposite over the adjacent. Is that not so? Sorry, over the hypotenuse, rather. Opposite over hypotenuse. Now, let us go back to our right angle triangle. What is the symbol, the alphabet we use to represent the opposite there? B, small b. Is that not so? Yeah. Good. So, it's going to be small b divided by, what is our hypotenuse? Small c. So, this is the formula for calculating sine theta. Anytime, any day, anywhere, in any subject, as long as you meet a shape called a right angle triangle. You have said something here. I said anywhere, any day, any time, any subject, as long as the shape you met there is what? A right angle triangle. Why have I emphasized on this? So that whenever you meet a shape, right angle triangle like this in any subject, I will talk more about physics. Because that is where you see much of these things. Are you following right? You don't need to be thinking, what do I do? What do I do? You are here today to learn what you need to do. On that day, it is a day of what? Attack. You know, your examiners, they'll be dribbling seriously to score you. Are you getting me right? You want to tighten your defense. You want to be the best goalkeeper. Am I communicating? And let me tell you, when it comes to competition most times, defending is not always the solution. Is that not so? Because if you keep defending, the pressure will be on what? On you. Sometimes you do what? You attack. And you prepare in order to attack. If you don't prepare very well, you cannot attack. Am I communicating, right? This is part of the process of your preparing very well. So that on that day, instead of your examiners to attack you, they will be the one doing what? Defending. The concept of right angle triangle. We are dealing with them on the board as we've seen. Let's move on to cos. The cosine of an angle, cos theta. What is it? I can't hear you. You're not speaking. Adjacent over hypotenuse. What symbol are we using for adjacent there? And hypotenuse remains C. So anyway, any day, any time, any subject, you see something about right angle triangle, look at the values given to you. If it necessitates you using cos to solve, that is the formula. Are you getting me? Of course, for you to use cos to solve, you must know the adjacent, and you must know what? The hypotenuse. Or, before this, let me ask you this question. How many things does this formula contain? 3 quantities. 3 things. It contains 2 sides. Is that not so? 2 what? 2 sides and 1 what? Angle. You can use this formula to solve any of them. Your examiner can give you the value of this angle, this side, and ask you to find hypotenuse. Are you getting me right? You can be given the value of this angle, the hypotenuse, and you're asked to find the adjacent. You can be given the adjacent, the hypotenuse, and you're asked to find what? The angle. It is a choice of your examiner. Do you understand that? Let's move on to tan. Tan theta is equal to, yes? Opposite over what? Adjacent. What is our opposite in this diagram? Small letter b. And what is our adjacent? A. Are you following? Good. So these formulas, you don't need to joke with them. You are expected to commit them to memory so as to remember them. How you use them in solving questions, we are going to see that, of course. These formulas already, this is 1 plus 1. Are you getting me right? Now there's something I want to show you quickly before we move on. I want us to divide sine theta over cos theta. I want us to do what? Divide sine theta over cos theta. We are looking forward that it is going to give us tan theta. So that starting from today, if you are not aware of this, you now know that if you divide sine theta, sine of an angle by cos of the same angle, it will give you what? Tan of that angle. Let us just quickly do something about it. It might likely just be a rough work. If I have sine theta and I divide it by cos theta, now from the above, what is the value of sine theta? B over C. Divided by, what is the value of cos theta? A over C. Mathematically, you know you have to keep B over C constant, exactly the way it is. Is that not so? You are dividing fractions. You are dividing fractions. So the top fraction, the numerator fraction, you keep it like that. This division sign, what do you do to it? Change to multiplication. What do you do to the denominator fraction? You inverse it. So it becomes C over what? A. This C will cancel, true or false? So do you now see that sine theta divided by cos theta is equal to what? Is it tan theta? B over A first. Now let us go back to equation 3. B over A is equal to what? B over A is equal to what? And B over A is equal to what? Therefore, tan theta is the same as sine theta divided by cos theta. Are you following, right? Because sine theta over cos theta gives us B over A, and B over A is tan theta. It's all right. We are done with this concept. 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 If you have any question, you can ask. If you have any question, you can ask. Finish up so I can wipe there and we proceed in what we are to deal with. Now there is one thing I want to establish quickly, after which we take our first question from our professional exam body. And that thing I want us to kind of establish, we call it Pythagorean identity. There are 3 of them, but we shall establish only one. How many of them I said? 3. But we will establish only what? One of them. The one that you make use of a lot at this level. Can I wipe this? Do you have any question from what I've done so far, from what we have learned so far? Is there any question? Okay, so we have established about 4 formulas: the Pythagoras rule formula or theorem formula, and then the trig identity, basic trig identity for this guy. I won't wipe this because we'll still use this guy. I want us to establish the formula that if you square the sine of an angle plus you square the cos of that same angle, it is going to give you 1. It is going to give you what? 1. That is what I want us to establish. But we'll be meeting all these things. I want to believe that you have actually put them down. So if I'm dealing with what I want to establish without you seeing everything, you can follow through. Pythagorean identity. Now, like I said, how many of them? 3. We have 3 of them, but we are going to establish only one. Are you here for JAMB lesson? There's a cyber cafe over there. Walk in and ask. Okay, so let us go. Are you there? We are going to combine these basic trig identities. Are you following, right? With Pythagoras theorem formula. You remember that theorem, right? C squared. Is that not so? We want to combine this guy with this ones, at least with equation 1 and 2 for sine and cos to establish that guy. Are you following, right? Now, we know that a squared plus b squared is equal to what? C squared. What if I decide to divide through by c? Look at this Pythagoras theorem. Now recall, c squared equal to a squared plus what? B squared. Now, I want us to divide each of these terms by c. Are you following, right? If I divide each of them by c, I'll have c squared over c squared equal to a squared over c squared plus b squared over what? C squared. What I did here mathematically, I have not committed any crime. Are you getting me? Because as I divided the left-hand side by c squared, I also did it to the right-hand side. So the c squared can still cancel out. I hope you know that. If you multiply here by c squared, it will remove this guy. Multiply by c squared to remove this. Do same here to remove. Are you following, right? So we are still okay. This formula you are seeing here is the same as this, although this is not a formula yet. We're trying to derive something. So what I did was to divide through by the hypotenuse square. Is that not so? Square of the hypotenuse. C squared over c squared will give you what? If you divide anything by itself, you get 1. Under indices, we said that power distributes over division. Do you still remember that? In fact, in our last class under sort, we also said something like that. Power can distribute over multiplication and what? Division. Therefore, you can still pull out that power. Am I communicating? Look at what I'm trying to say. I have a squared over c squared. This a squared and c squared here, you can decide to pull out the common power a over c, and then you do what? Square them. Are you following, right? Since power distributes over division, you can still open up this bracket. It's going to be a raised power 2 and c raised power 2, giving you back this. Are you following, right? Now, if I apply it here, what would this become? Please, I would like you to be looking at this as I show the working here. A squared over c squared, look at it. I told you it can still be written as this. Is that not so? Yes, sir. All right, let's go back to our basic trig identity. A over c alone, from our diagram. A divided by c alone is equal to what from our basic trig identity? So in place of this a over c, all raised by 2, I will write cos theta, which is our a over c, and do what to it? I will square it because a over c alone is cos theta. Are you following? Because of the angle. Then plus, let's do same for b squared over c squared. Oh, you get that right? Good. Because b over c alone is what? sine theta. And this guy is squared. So you do what? You square it. We can now conclude, therefore, you see this cos theta squared? It is actually written like this mathematically. Let me transfer the formula there. Are we learning? Is there any problem? If you have any question, you can always feel free to ask. Those in the social science field that are going to take math in their JAMB, cool, you just have to learn these to smash questions on them in your mathematics. Are you following, right? Those in the science field, you are not learning this just because of math. Am I communicating? You're not. As a matter of fact, whenever I teach science students this topic, I am more of looking at their physics. Are you following, right? Yeah. So you have more application of it. Cos theta all raised to power 2 is written as square cos theta. Sin theta all raised to power 2 is written as square sin theta. And this is the way we write it. I want to start from here anyway. Doesn't matter. I want to write sine first. Are you following, right? It's going to be written like this. This is pronounced square sin theta. So anytime you see this thing, know that it is sin theta raised to power 2. Do you understand that, right? For example, if I give you something like this, what does it mean? Sin 30 raised to power 2, which means you have to find the value of sin 30 first. Are you getting me? Then you raise it to power 2. Last time under projectile, for those in the sciences, under projectile, there was this formula of maximum height. Maximum height is equal to the initial velocity square, that is u square, and then square sine theta divided by 2g. So get to understand the meaning of this expression that you have it. The same thing, we go to that of cos. We are going to write it as square cos theta. Are you following, right? For this guy. And everything will be equal to what? Everything will be equal to what? I have a question I'm going to ask you. And I don't want you to think twice before you give me the answer. Because if you are thinking twice before giving me the answer, you may fail it. You may get it wrong. Are you getting me right? Now I'm going to interpret this formula for you. This will be question what, please? Formula number what? 4 or 5? Should be 5. Pythagoras theorem number 1. Then we had 3 trigonometric identity, making it 4. So I didn't label the Pythagoras theorem on, but it does not matter anyway. You can label your equation with anything you want. But let me just fix it as 4. Let me use 4. So it will align with what you have there. Now look at the interpretation. This is the interpretation of this formula. It's telling you that if I give you a particular angle, let us assume you have angle 30 now. Are you getting me right? If you do sine 30, whatever you get, you square it. Are you getting me right? Plus cos what? 30 still. Are you following, right? Whatever you get, you do what? You square it. The answer must give you 1. Which means you don't need to solve anything there. Are you getting me right? It is an identity, so it is expected that you should know it. But like I said, there are 3 of them. There are 3 trigonometric identities. Now, YouTube channel, you have works on all the 3. But I am much more interested in the ones you need for the exam you are going for. If they are testing you on anything that has to do with that, this particular one is the one they usually test you on. There is that one that makes use of square sec and square cosec. Are you getting me? That is when you now start bringing the inverse of basic trig identities. Basic trig identities include sine, cos, and what? Tan. And it's this sine and cos that I've used to generate this formula. You have the one of cosec square, sec square. You know, sec is 1 over cos. Is that not so? Cosec is 1 over sine. They have that one that also contains cot, which is 1 over tan. But I am not discussing that in this class. And we might not just discuss it because you may not need it for your professional exam you're preparing for. If they are pushing you, stretching you any further, this is the one that you might have to use, as the case might be. So, what is the value of this? In exam, assuming your examiner tells you to evaluate sine square 3 over 2 plus cos square 3 over 2. What is the answer? 1. There is nothing to solve there. Because the angles we have here, they are the same. 3 over 2, 3 over 2. And you have sine of this angle, you are squaring it. Cos of that same angle, you are squaring it. From this identity, the answer must be what? 1. But look at this one. Let me set the trap. Let me set the trap. Sine square 30 plus cos square, that is square cos 45. What is the answer? Okay, option A, 1. Option B, not 1. What do you say? Not 1. Why can you say that this guy is not equal to 1? What makes you say that it's not equal to 1? Correct, the angles are not the same. If the angles are the same, it's equal to 1. All right, I think we are done with all the concepts of right angle triangle. It is now time for question. It's now time for what? For question. It's now time for question. And I think before this question, there is one more I was supposed to actually establish before the question. I'm going to establish it, please, before we move. Okay, I'm going to establish it. Yeah, let me establish it before question. I'll just write relationship between sin theta and cos theta in a right angle triangle. In a right angle triangle. Apart from this relationship, are you getting me right? Apart from this relationship, there's another relationship that I want you to know. That relationship relates sine and cos directly, not their square. Are you getting me right? And it applies to right angle triangle only. It applies to what? Right angle triangle, most generally only, yeah. Although you may have other forms of it for angles that are not right angle triangle, maybe for obtuse angle, or reflex angle, but I'm limiting you to that of right angle triangle for now yet. If you add this angle and this angle together, this angle plus this angle, it will give you 90 degrees. In a right angle triangle, if you add the other two angles, are you following right? It will give you what? 90 degrees. We call it complement. We call that complementary angles. Are you following right? Complementary angles are angles that add up to give you what? 90. And I think supplementary, they add up to give you what? 180. Do you understand that, right? Now, on the basis of that, we can actually use that concept to say, if you know this angle, to get this one, you will subtract this from 90. Is that not so? To get this angle. Therefore, if I give you something like sin theta, it will be equal to cos 90 minus theta. The value of sin theta is equal to cos 90 minus what? Theta. Where theta is expected to be less than 90. Are you following right? Because this thing is for acute angles specially. Are you getting me right? And it happens based on this concept of special angles. I've told you about special angles before. If you come to the first quadrant, don't write this. Don't write it. I've dropped the video lessons for you people before. I will still drop it again this weekend. This is 0 degrees. Is that not so? This is 90 degrees. Is that not so? Special angles in this first quadrant. This is the first quadrant, second, third, and fourth. This first quadrant measures all angles from 0 to 90. Are you getting me? This point is 180 degrees. Here is 270 degrees. Then back to what? 360 degrees. So this is first quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. All angles between 0 to 90. That is what you study in right angle triangle. And I want to limit ourselves to special angles because in your exam, if JAMB is giving you questions on this, they will give you special angles. As a matter of fact, if everything goes well, JAMB does not have the right. I repeat, JAMB as an organization that sets UTME exam does not have the right to give you any angle that is not what? A special angle. They don't have the right. The reason is because their system there, the calculator there does not contain these special angles. Are you following? And you're not, sorry, it does not contain trig functions, sine, cos, and tan. And you're not allowed to use what? Calculator. So you are expected to be able to evaluate these at hand, as an offhand rather. You should be able to evaluate them what? Offhand. And for this to be possible, a special angle that will be given to you. And I gave you the secret of getting to know your special angles. You use your 30, 15, 15, 30 to generate it. For those that were not in the class when I explained that, all these angles I showed you, they are special angles. Are you getting me right? 0, 90, 180, 270, 360. They are special what? Angles. Now I want to generate other special angles between them. We want to generate other special angles between them. If you come to any quadrant, to get the next special angle, what you do, you add 30, you add 15, you add 15, you add 30 again. So from 0 degree, the first special angle will be what? 30 degrees. By adding 30 to 0, is that not so? Remember I said what you're adding is what? 30, 15, 15, 30. I hope you are together, right? Now you have added 30, you're now adding what? 15. If you add 15 to 30, what will you get? 45. What do you add next? 15 again. If you add 15 to 45, what will you get? 30, 15, 15. So what do you add last? If you add the 30, you will now get from here to here to be that what? 90 degrees, which is what we have here. To get to that special angle, you continue again. You know you have entered second quadrant. Is that not so? You still continue. 30, 15, 15, 30. If you do that, it will land you on 180. Repeat again. 30, 15, 15, 30 like that. So those angles are the angles that JAMB can give to you. If they give you any other angle apart from these special angles, then they have gone against their policy for the nature of exam question they're asking. But most generally, they won't give you beyond that. Both in your physics for those that, for our science students. So you're expected to know the values of those angles. Are you getting me right? Their sine, their cos, their tan. Now, our focus is in the first quadrant. Are you following right? Look at this relationship. If I tell you to find cos 30, sorry, I tell you to find sine 30 rather. Sine guinea. Sine what? The answer you will get will be the same as cos 90 minus what? 30. Cos 90 minus 30 will give you what? I am saying, if I say you should find sine 30, the answer is still the same as cos what? Cos 90 minus 30. 90 minus 30 is what? 60. So the result of sine 30 is equal to cos what? 60. So that if you know the value of sine 30, you don't need to bother yourself evaluating cos 60 again. It's the same value, so just to copy and put. Are you getting what we are talking about here, right? Good. What if I say you should evaluate sine 45? In terms of cos, it will be equal to what? I say in terms of cos, it will be equal to what? Still cos 45, is that not so? Cos what? 45. Because all you have to do is 90 minus that what? 45. So that is the idea, the essence of this. And let me show you one type of questions that, one type of question, as it may be, that you can actually be dragged into using this. Are you following right? I can tell you, find the value of x. Are you following right? Given that sine 90 minus x given sine 90 minus x to be equal to cos, let's say cos 60. Find the value of what? Of x. Given that sine 90 minus x is equal to cos what? 60. Find the value of what? X. You create a simple equation on this. To solve it, you make both sides to get the same trigonometric what? Function. Are you getting me right? See, sine theta is equal to cos 90 minus theta. The same thing, cos theta is equal to sine 90 minus what? Theta. It goes the two-way round. I've given you this for sine theta. If I were to write for cos theta, it will still be cos theta equal to what? Sine 90 minus theta. So I am telling you that you need to take note of this. Are you following right? As you prepare for maths, especially. Any one of them is 90 minus the other if you change the trig what? Function. So let me ask you now. Sine 20 will be equal to cos what? Which will give you cos what? Sine 20 is equal to cos what? Cos 70. Okay, now. Cos 60 is equal to what? Sine 30. Cos 90 is equal to what? Cos 90. Cos 90 is equal to sine what? Sine 0. Now, is that not so? And if I say you should use your calculator and evaluator, you will see them. Are you following right? Cos 90 is equal to 0. Sine 90 is also equal to what? 0. Okay, let me flip it. Sine 90 will be equal to cos what? Sine 90 will be equal to cos what? Cos 0. Sine 90 will be equal to cos 90 minus 90. Is that not so? Yes. Which will give you cos 0. Sine 90 is 1. Cos 0 is also what? 1. Are you following? So please remember this detail I've given to you. And I've shown you something related that you can be tested on using this relationship. Like in this case now, sine 90 minus x equal to cos 60. And I'm telling you to find what? X. All you have to do is simple. Come to this cos 60. Replace it with what? Sine 90 minus 60. Is that not so? Please let me write the two out for you so you copy them. Cos theta is also equal to sine 90 minus theta. So just as a rough way, don't copy. Look at it. Just don't copy this thing I'm about to do. This is what you're meant to copy. Copy down the relationship. If I give you, like I said, sine 90 minus x equal to cos 60, and I say you should find the value of what? X. All you have to do is simple. Sine 90 minus x will be equal to sine, you come here, 90 minus what? 60. Since you have sine on both sides, are you following? Their arguments, the angle they are carrying, the angle they are bearing must also be what? Equal. Are you seeing how we create the simple equation? Are you following? You have succeeded to transform both sides to the same trig function. Automatically, their angles must be what? Equal. Are you following right? If you make 90 minus x equal to 90 minus 60 and you solve, what will you get? You get 60 as your answer. Is that not so? So x will be 60 in that case. X will be what? 60. If you make 90 minus x equal to 90 minus 60. If you solve that thing, x will be equal to what? 60. Which agrees with what I've told you. If x is 60, sine 90 minus 60. 90 minus 60 will give you what? 30. That is, we now have sine what? 30 here. Equal to cos what? 60. Because of their complementary nature. Are you following right? Okay. We have really done justice to this. So let me wipe the board. And like I said, we shall now pick some questions to solve. We know we are done with this guy. Our first question. Are you there? Please write. This is JAMB 2015, question 27. In a right angle triangle, this is our question 1 here. In a right angle triangle, if tan theta equals 3/4, if tan theta equals 3/4, what is cos theta? What is cos theta? If tan theta is equal to 3/4, what will be the value of cos theta? I will give you the options, even if I don't like creating options sometimes. Oh no, what's going to be the value of cos theta minus sin theta, please? What's going to be the value of cos theta minus sin theta? Option A is 1/5. Option B is 2/5. Option C is 3/5. Option D is 4/5. Solution. Let's see how fast we can solve this. When you see questions like this in the exam, how do you handle it? Are you there? There are 2 approaches that you can use. You decide whichever. However, there is one of the approach I did not show you. Remember I told you in Pythagorean identity, there are how many of them? 3. But I gave you only what? 1. So for that reason, we won't be able to go through the other formats. Rather, we'll go through the format of so far, which is what many students prefer. Because most of us are used to all these sin theta, cos theta. Are you following, right? Opposite over hypotenuse, adjacent over hypotenuse. Hence, most times we like going through that part. But if you knew all the Pythagorean identity, say that you've memorized them, the Pythagorean identity, there is one that could have solved this directly for us that will make it easier. But all the same, it doesn't matter. Don't stress yourself about that. This one will also work for us very well. Solution. Now we are given tan theta to be equal to 3/4. Now what is the implication of this? Tan theta is what over what from what we have learned so far? Opposite over what? So if you're telling me that tan theta is equal to 3/4, what will this 3 be in your right angle triangle? You are very correct. So I don't have time. Let us just write opposite over. And what would this 4 be? Adjacent. Therefore, my dear friends, you know the value of the opposite of the right angle triangle now, and you know the adjacent value. Is that not so? Is that not so? You know that if you are given 2 sides of a triangle, you can calculate the third side using Pythagoras theorem. Is that not so? So if in this right angle triangle that this question was taken from, they didn't draw the right angle triangle. They don't have any need of drawing it. They don't have any need of sketching it. They have given you a trig function from which you can now define your opposite and adjacent. You know 2 sides of this triangle now. Remember, what you are asked to find is cos theta minus what? Sin theta. Is that not so? To calculate cos theta, it is what over what? Cos theta is equal to what over what from right here. Again? And from the question, we know our adjacent. Is that not so? Do we know our hypotenuse? No. Which means you must find a way to get the hypotenuse. Am I communicating? I come again. I'm going to repeat myself. What the examiner asked us to find is cos theta minus what? Sin theta. To get cos theta, we need the formula adjacent over what? Hypotenuse. Good enough from the question, we know our adjacent. The value of the adjacent is what? 4. Then minus sin theta. To calculate sin theta, it is what over what from the right angle triangle? Again, bringing hypotenuse again. Is that not so? Good enough from the question, we know our opposite, isn't it? So what is our main problem in this question now so that we can be able to solve this thing? Hypotenuse. And that is why, my dear friends, will have to reach out and calculate the hypotenuse of this right angle triangle. Am I communicating? Now you know the opposite, you know the adjacent. Before the D-Day, you already have your Pythagoras theorem fully, the formula here. Is that not so? So let us calculate the hypotenuse. Let me write grammar. Don't go and write any grammar in the exam hall. But hypotenuse, which we are going to use C for it. Are you getting me right? Is equal to opposite square. The opposite, let me just write it, this square plus what? Adjacent square. Square of the hypotenuse. Square of the hypotenuse. So hypotenuse square, which I'm using C is equal to this. You are aware of the formula, is that not so? Let me not use this format. Let's use our symbols directly. Get used to the symbols so you don't go writing too many things in the exam. I don't need that. Now, if you say that C is our what? Hypotenuse is going to be plus B square. Is that not so? So that our C square will now be, adjacent is what? Our adjacent from this, I'm using A as adjacent. 4, is that not so? You square it. Then let's use B as opposite. Are you there? And what is the value? 3. You square it. Are you getting me right? Do you understand this? Do you understand that? From the question, we're given tan theta value. Tan theta is 3/4. From that tan theta, we know that tan theta is 2a. Is what? Opposite over what? Adjacent. So if you are telling me that tan theta is 3/4, and I know from what we have learned from the GMAT 41's JAMB and Y class today, that tan is opposite over what? Adjacent. All you have to do, opposite, equate it to the numerator of that 3/4. Are you getting me right? Adjacent, equate it to the denominator. So you know your opposite, you know your what? Adjacent. Then use Pythagoras theorem to calculate your what? Hypotenuse. Because you need your hypotenuse to solve this thing they ask you to solve. That is what we are trying to do. C is our hypotenuse. And from Pythagoras rule, we have gotten this formula before. Is that not so? Right? Can I proceed? Yes. Without wasting time, I have told you that before the day of your exam, you should make sure you have excellent knowledge of your multiplication. I always sing that in all of my platforms, whether physical class, online class, whether you are in primary school, you are in secondary school, you are in university. Go and learn, memorize your multiplication. There are no two ways about it. Some person will tell you there are tricks or whatever. Yeah, I know there are tricks of maybe trying to work on your multiplication, but none of those tricks compared to your having this table at heart. You know it and you can say it offhand any day, anytime, anywhere. It's a function of memorizing it. It's not about learning a trick of getting it. Some will tell you if you want to do 3 times 3, you draw 3 lines like this, draw another line like this, 3 times 3. Now you come to this point. 3 times 3 is what? 9, Abi? You come to all these points where they met and start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3, 9. Okay, you are asked 5 times 2 is what? 1, 2, 3, 4, 5. 1, 2. Are you there? 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't want to say that these things are rubbish. Let me not just be too harsh that. Because I know that sometimes, somehow, some of you are seeing some of all these tricks that some persons do online. Are you getting me right? It is not wrong, just for self-improvement, but not for you to use it in exam standard. We grew up learning and having multiplication table at heart. It's not beyond you people. Please, you need that table at least from 2 to what? 9 times table, like I've always said. Have it here. That is one of the things that can save you if you find yourself seated in your mathematics what? Exam. Because this thing activates your brain and it helps you to process. Your ability to memorize that table simply shows that your brain has skyrocketed in the level in which it processes information and store information also. Do you get that right? You can set a goal within 1 week. We are talking 2 to 9 is how many tables? 7, is that not so? 2 to 9 is 7 tables. I'll be 8 tables rather. 8 tables. Give yourself 1 week. Every day practice one. Every day practice one very well. Even if it means you deny yourself from the time you eat. You know, I always laugh at people sometimes. These days now that the back of your book, it is Indomie, egg, and tomatoes that they draw at the back. During our days, I keep telling you guys, landmark. I will never forget that notebook. You have all those metric quantities, multiplication table, conversion of time, conversion of a length, volume conversion, area conversion, and these are things you use in your field of study science and mathematics. Go and memorize that table. Why am I saying this? Look at this question. I've shown you some of the tricks that you can have. There are many of them. An individual may come up with anything, but hey, none of them compare you consciously memorizing the table. Are you following that? Imagine the example you want to do 4 times 4. You now start drawing all these lines. You see the in and out. Please, let's go. With your excellent knowledge of multiplication, from here immediately you can get your result. Are you aware? You don't, all this I'm doing, I'm wasting my time. That's the truth. But of course, I want to carry all of us along. 4 squares is 4 times 4, which is 16. Is that not so? 3 squares is 3 times 3, which is 9. 16 plus 9 is what? 25. 6 squares is equal to 25. 6 squares is equal to what? 25. What you are looking for is C, not C squared. Am I communicating? So you have to remove the square from what? C. To remove square from something, what do? You take square root. Remember, at this point, you have C squared equal to 25. Is that not so? If you take square root of C squared, the square will cancel out. You'll be left with only C. Are you getting me right? Then you take square root of 25. Square root of 25 will give you what? 5, without thinking. What helps you to know that square root of 25 is 5? What helps you to know? Multiplication table. Because you know that 5 times 5 will give you 25. Therefore, if you reverse the process by taking the square root, you get 5. Don't play with your multiplication, please. The hypotenuse is 5 now. Are you following? It is at this point you are now ready. It is at this point you are now what? Ready to calculate sin theta minus what? Sorry, cos theta minus sin theta. And let me tell you, with your excellent knowledge of multiplication, you can actually solve this question just within 2 lines of solving or 3 lines. Are you getting me right? Either 2 or 3. Yes. You are in the class as GMAETS for the one is teaching you this and how this is being done. Is that not so? In exam hall, attention on the board, all of you. In exam hall, you have a question like this. Let me ask you. Will you go writing these things in your JAMB situation? Even in WAEC, under objective case, you don't write out all these things. It is in theory. Are you following right? You show your what? Workings. In exam, I don't need to write that tan theta is 3 over 4 opposite over adjacent. No. From here already, I know that this guy is opposite. Are you following right? And this one is what? Adjacent, because I know what tan means, TOA. And immediately in the exam hall, I have been able to interpret that this is opposite and this is adjacent. The next is to calculate my hypotenuse directly. Are you getting me right? Whose formula I already what? Have, at heart. And if you are applying Pythagoras theorem, you know that hypotenuse will be equal, square of hypotenuse will be equal to square of this plus square of this. Is that not so? Is it not just to go straight? Square of hypotenuse will be 3 square 9, 4 square 16. Add, you get 25. All these things, your brain can process it within 3 seconds. That is how powerful your brain is. Yes, within 3 seconds, if you understand this and you have your multiplication table at heart, don't doubt what I am telling you. One question in your exam is within 40 minutes or less. It's not more than 40 minutes. If you are using 40 minutes, it means once it is exactly 2 hours, that is when you'll be answering your last question. Are you following? You don't have to do that. If each question should take at most 40 seconds, was it minutes I said? Yes. I'm sorry, in seconds, please. 40 seconds. On your own, as you're preparing for this exam, you should tell yourself that you want to attack and solve a question, answer a question within 15 seconds. And let me tell you, there are many of these exam questions that are solvable within that time. Say this question, it shouldn't take you more than 15 to 20 seconds as a student. Your challenge is your multiplication knowledge. That's the truth. Because like I said, that is one thing that could help you process the working faster. Are you following right? After understanding how it's been done. Anyway, let's move on, please. I have gotten my hypotenuse C. Are you following right? Therefore, we can now obtain our cos theta. Are we together? Let's get cos theta. What's the value of cos theta? Cos theta is adjacent over what? Look at everything you solved and what was given to you in the question. What is your adjacent? Which number is representing adjacent? So it's going to be 4 over hypotenuse. What is our hypotenuse? Okay, next is sin theta, because we are evaluating cos theta minus sin theta. What is the value of sin theta? 3/5. Opposite over what? Hypotenuse. Is that not so? Sin theta is opposite over hypotenuse, and opposite was given to us in the question 3/hypotenuse 5. And the examiner said you should evaluate this. You know, we took our time solving just this one question. There is a reason for that. I, for one, am not the person that believes in too many questions. Also, you see, in maths, it's much like you are repeating the same thing. Any day, anytime you are given a question like this, either they give you sin theta equal to something over something, or they give you cos theta equal to something over something. They can ask you to evaluate any combination of the trig functions. Are you following, right? And the approach follows the same process. Now that I've gotten my cos theta value and sin theta value, therefore, it means that cos theta minus sin theta will now be equal to, you fix up the values. Are you getting me, right? We're now going back to what they asked us to actually find. What is the value of cos theta? 4/5 minus what's the value of sin theta? Is this not a fraction? When you are adding or subtracting fraction, which knowledge do you use to? LCM, is that not so? What is the LCM of the denominator? 5, is that not so? Therefore, our final answer, cos theta minus sin theta. I'm not going to show the whole working. We know the LCM to be 5 already, is that not so? So, you come over here, you have over 5, something like this. 5 divided by 5, 1. 1 times 1, you know, something like that. But you see, whenever their denominators are the same, don't bother yourself. Just pick that common denominator, then work on the numerator directly. Are you following? 4 minus 3 will give you what? Therefore, the value of cos theta minus sin theta for this question is 1/5. What's the option? You see, with this one question, we have finished any such kind of question they can give you on something like this. Are you following? Remember, like I said, the question could have been given to you instead of tan theta, it could have been given in terms of sin theta. Are you getting me? And it could have been given in terms of what? Cos theta. Copy out that. If you have a question as you're writing, please ask. Make sure you continue to study every day. There is no day that should pass you by without you studying what you've been taught. When I'm going to run out full revision, you know, at this point, I teach you with self-question, I teach you with self-question. 2 weeks to the exam, 1 week to the exam, you know, depending on how far we're able to cover the outline fully, I enter here. Nobody's teaching anything again. It will be question, 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 question. Am I communicating? That time is expected that you've covered all of this. Your foundation is stronger now. Are you following? So make sure you're following through. You know what we do at GMAETS 41, it's not just all about coming to say answer past questions. You don't answer what you don't know, like I've always said. As a student, you have to be taught first. Is that not so? Yes. To understand it. So when questions are being solved, it will make sense to you. Okay, let us rush this question. Let us what I said. Rush this particular question. I use the word rush. I use the word rush so that you will understand that in exam hall, this thing should not take you time at all. It should not take you time at all. Let us see. Are you there? Question 2. Given that sin 45 is equal to 1/√2. Evaluate. I will take you a step further. Although we did not write on the board, the value of cosec, sec, and cot. But I kept telling you what those guys are. Is that not so? Cosec is 1 divided by sin theta. Cosec theta is 1/what? Sin theta. Sec theta is 1 divided by cos theta. Are you following, right? Tan theta is 1 divided by Cot theta. Cot theta is 1 divided by tan theta. Store that one in your kidney. Cot is 1 over tan. Sine, cosec is 1 over sine, and sec is 1 over cos. Save that information in your kidney and liver. Now I said I wouldn't give it the opportunity to write down. Because I want to convert this question to something else now. Are you there? I want to convert it to something. And this is what I want us to do. Evaluate cot. Sorry, this is sine theta rather, not 45. Sine theta equal to 1 over root 2. Evaluate cot theta plus cos theta. In fact, let me even try to make it a bit complex. Over cosec theta. I just want us to do this. So you get the whole idea. And I'm going to be fast. If you see something like this anytime, you don't need to be scared. It's simple. Are we ready? So let's go. From the question, what they gave to us is sine theta. And the sine theta is equal to 1 over root what? 2. From our trig identity, sine theta is equal to what over what? Opposite over what? So from the question given to us, what's the value of opposite? 1, is that not so? Yes. What's the value of hypotenuse? Root 2, is that not so? That's good. Now that we know our opposite, if I use B to be opposite is equal to 1, and C as our hypotenuse is equal to root 2. We may not solve this to the end. I just want to create a pattern for you so that you'll be stabilized with this particular question, as in this type of question. Are you following, right? You know, with this, we can get our adjacent, true or false. Do we even need adjacent here? How would you know whether you need adjacent or not? Look at the question you're asked to evaluate. You have to evaluate what? Cot theta. And cot is 1 over tan, I said. Is that not so? Yes. In tan, don't you have adjacent in it? You have. So that is why you need it. Are you getting me right? Now you are asked to also evaluate cos theta. In cos, don't you have adjacent in it? So you see the reason why you need to find the adjacent. Are you getting me right? So from here, we can get the adjacent. Let us apply Pythagoras theorem. Adjacent, we don't know. Remember that Pythagoras theorem says if you square the hypotenuse C, it's going to be this squared plus this squared. Is that not so? So without wasting time, let us fix. And I'm not going to show all the working. Please be following as I am doing it while you are also writing. Connect your brain to what I'm doing. You must be writing at the same time and be following what I'm doing. If you have a question, you ask. Because I don't want to show values here too much again. C is our hypotenuse. Is that not so? What is the hypotenuse from the question? Square root of 2. Is that not so? Yes. Now, if you remove C and you fix square root of 2 here, this C is raised to power 2 on its own. True or false? So you're going to get square root of 2 or raised to power 2. True or false? What would the square do to the square root? You cancel it now. Is that not so? So that what you now have here is actually 2 equal to, you come to A. Do you know the value of A? Do you know the value of A? So you're going to have A squared. If you go home, when you return home, you can do your step-by-step substitution. Am I communicating? That you don't need it in the exam hall. That is what I've told you. Your ability to work on that multiplication will help you a lot. I know what I'm saying. I am a benefactor of that guy from 2007. I've shared 2017. I've shared that story with some people time and again. Multiplication, you don't joke with it in maths, in anything calculation-related subjects. Now come to this B. What is our B? Our B is 1. Which is the opposite. Is that not so? If you square 1, what will you get? Now from here, without thinking, what is the value of A? If I tell that A is 1 now, some of you start looking at it. Your ability, the ability of your brain to go ahead of you. Are you getting me right? Because that is one secret of students, being able to blast high high score in their exam. You may do it step by step on your own, but see, it is not on the day of exam that you do it step by step. Your step-by-step analysis of work comes when you are preparing. Are you getting me right? So that all these things, you get the whole idea, it will reside in you, in your brain, permanent residence. When you enter exam hall, you'll be fast in processing all these things. Remember that any second you use in writing anything down as a way of trying to solve, show working, it matters. Is that not so? 1 second can make you score 300. 1 second can fall you from 300 to 299. True or false? Think of your system goes off, it shuts down just in a second. So if it happens that you are wasting time trying to show all workings or the things you should allow your brain to process, go ahead of you. You want to do everything, you are solving every. It now happens that you are left with one question that is supposed to give you 350 as a score. And unfortunately, you're not able to beat up the time. The system goes off. Can you score the 350? No. So that is why you want to know how to manage your time. Please, let's move on. Our A is 1 here because at this point you collect like terms. I hope you know that, right? 2 minus 1 will be A squared. And 2 minus 1 will give you 1. You take square what? Root. Square root of 1 will give you what? 1. Okay, we have gotten our adjacent. Let us now go back here and substitute. But remember what I said. If you want to write it somewhere in your note, you can write cot theta is equal to 1 over what? Tan theta. Cot theta is equal to what? 1 over tan theta. Let us substitute here now. We are required to evaluate cot theta plus cos theta divided by cosec theta. Cosec is 1 over sin theta. Cosec theta is 1 over sin theta. So if you want to write this thing as a rough, anywhere you have to now write. So this is going to be equal to, you come to cot. Your brain will process quickly that cot is 1 over tan. Are you getting me? 1 over what? Tan. So this is going to be 1 over tan theta. Look at all the values we have on the board. Tan theta is equal to what over what? I mean in terms of the trig functions and identity, tan theta is what over what? Opposite over what? Adjacent. Then you now come to your question. What is the opposite here? 1, which is B. What is your adjacent here? 1, which is A. So, your 1 over tan theta. Tan theta in this case will be 1 over 1. We said, is that not so? 1 over 1, you fix it here. See, what I have under here is my tan. This is 1 over tan theta. Tan theta is 1 over 1. Because we are evaluating cot. And look at cot here. Are you getting me? Cot is 1 over tan. 1 over the value of tan theta. Tan theta is opposite over adjacent, which is 1 over 1. Are you getting me right? Add it to cos theta. Cos theta is what? Adjacent over what? Hypotenuse. What is your adjacent here? 1. Hypotenuse is what? Root 2. Are you following right? Then you now divide it by cosec theta. Cosec is 1 over the value of sine. Are you following? So this is going to be 1 over, what is the value of sine given to us? Sine theta. 1 over what? Root 2. That is it. So you see that you fixed numbers here. You are just dealing with the normal numbers. For you to simplify that further, you have fraction in the numerator and then divide by something in the denominator is simplified. I will give you a call. I need the discussion. Dear friends, have we understood the process of all these things? Have we understood the process? Depending on any trig function given to you in the question. If they give you sin theta value, it means you know opposite over what? Hypotenuse. So go and get your word adjacent. If they give you cos theta value in the question, if I say that cos theta is, let's say, 1 over 5, I'm assuming, then it means they have given you adjacent value and what? Hypotenuse. Therefore, go and find what? Opposite. So evaluate anything they ask you to evaluate. All right, I'm wiping this part. I think what we are struggling with now, which I am still encouraging you friends to work on, is that thing that will help your brain to be processing fast. Are you getting me right? Very important. And I've exposed that thing to you. Multiplication. I'm going to be fast from here. What they ask us to evaluate, which is cos theta plus cos theta, cot theta plus cos theta over cosec theta is now equal to 1 over 1 over 1. We give you what? 1 plus 1 over root 2. Then all over, look at this expression here. 1 divided by 1 over root 2. Do you know mathematically this root 2 will go up? Are you aware? The root 2 will go up. So there is no time to waste. I'm going to take it up here. So if it goes up, it's going to be just root what? Root 2 there. Can we find the LCM of this guy? Because the numerator is a fraction, isn't it? The numerator is what? A fraction. So you have to find LCM. What's the fastest way of getting the LCM of this guy? If I give you 2 plus 1 over 3, what's the fastest way of getting the LCM? Speak, no time. As in talk about, tell me how you do it. You have numbers, so use it to say it and speak louder. Let's move. You are talking what? Yes, please, audible. 3 times 2 plus 1. You're telling me this over 1. How does it concern me? I want you to know how fast you can do addition and subtraction of fraction when you have a whole number and what? A fraction. We've talked about that time and again. So you don't go doing all these things you do. LCM is 3. 3 divided by 1, 1 time. You don't do that in exam. You should go beyond that. This thing to work out the LCM, since this is a whole number, this is a fraction, it's going to be the denominator times this, plus whatever you have here. Are you getting me right? Then everything over the 3. Apply that here. This is going to be, oh yeah, let's go. You're not audible. Root 2 times 1, we give you what? Root 2, Good, so you have root 2 plus 1, then over what? Root 2. That's over that same denominator there. Are you getting me? Yes. Divide everything by what? Root 2. Are you getting me right? This times this plus this gave us this expression. And you know that the denominator of that numerator part is root 2. Look at it. Then divide everything by this root 2. Are we together? Are we together? Now look at the numerator is a fraction. The numerator is what? A fraction. The numerator is a fraction. The denominator is a whole number. Mathematically, this root 2 will come down. I don't know what you were saying as you go, or what is going on there. This root 2 here will come down. Is it a challenge some of us have? Is that we do not like, most of us don't like applying that knowledge. We think it is little. We don't like applying it to complex cases. All these things are the same. Most of you now seated here, you can be able to evaluate this. If I give you 1 over 2 over 3 over 5, you can do this. Is that not so? You know this root 2 standing alone here is over 1. Are you aware of that? Are you aware of that? Most of you can do this. The way you solve this guy, is it different from the way you solve this one? Is it different? Yeah, tell me what to do here. 1 over 2 times what? 5 over 3. Is that not so? Yeah, apply it here. Be audible. You people are not audible when you talk. Root 2 plus 1 over what? Are you getting? This root 2 will multiply. This root 2 will multiply the root 2 under. Is that not so? Root 2 times root 2, we just treated solve. Square root of 2 times square root of 2 will give you what? We give you 2. Is that not so? Square root of a number times square root of that same number will simply give you that number. But if you want to write that square root of 4, because square root of 2 times square root of 2 will give you square root of 4, which if you find its square root, you're going to get what? 2. We are done with this question, you know. Therefore, cot theta plus cos theta divided by cosec theta, the value is equal to root 2 plus 1. If you multiply all these things by 1, it will still be that same term. Is that not so? Then all over 2. This is your answer to that question. Follow behind. I'm showing you where to follow. I hope you are cool with this, right? If you have any questions, please, you can ask. If you have any question, you can ask. If you have any question, you can ask. Let us take our next question in the absence of any question from you. Most of these questions are similar to what we have done there so far. You have a question there? Number 1, 2, theorem. It's the same thing. I don't want us to waste our time on that again. I'll just copy the question. This is from WAEC, right? This is from WAEC. And you know, I've always said this, WAEC, JAMB, everything say the outlines are same. They are the same, nothing similar. The only difference between JAMB and WAEC is that WAEC conducts theory exam. Are you following, right? That's just the only difference. Topics covered are 99% the same. Now, this is a question someone gave to us, and I think I am going to give it to you as an assignment. I'll give it to you as what? Assignment. It cannot be classwork. We don't have time for you to do the classwork now. Okay, let's go. This is 2017 WASA theory part, question 10. Given, so I'll write it assignment. You see, I'm giving you this as assignment because I have guided you to see how we handle even tougher, as in a case that you might think is tough. Are you getting me right? What I saw here, or what I'm saying here rather, is simpler than I imagined. Given that sine x is equal to 5/13. This x is the same as theta. Are you getting me right? It's the same as what? Theta. Sine theta equal to the sine x. They can use any alphabet to represent the angle. So given that sine theta is equal to 5/13, already some of you, if not all, but I want to believe that all of you already knows the two sides of the right angle triangle given to us in the question. Is that not so? With this thing here. That is why I told you can process this thing as fast as possible. This questions like this ordinarily shouldn't take you more than 15 seconds, like I said. Immediately you are reading the question, you already know what parameters, what values are there. Okay, given that sine x is equal to 3/5, now, comma, 0 less than x less than 90 degrees. What they are telling you is that the angle here is an acute angle. Are you getting me right? It is an angle less than what? 90. Because when you are dealing with right angle triangle, it's actually a 90-degree total angle you are dealing with. Is that not so? I drew the diagram. I showed you that that angle specially focuses on what? 90 degrees. That was why when I drew the 4 cardinal points to show you the special angles, I only focus on the first quadrant from 0 to 90, where we got 0 degree, 30, 45, 60, and 90. I did not go to the second quadrant. Are you getting me right? Because that is not the focus of what we are dealing with here. So this parameter defined here is to tell you that the angle is an acute angle, less than 90. Hence, it is subject to right angle triangle. Find cos x. You will see the reason why I now told you that I won't solve it. You should take it as an assignment. Minus 2 sine x all over 2 tan x. Now from the question, what 2 sides of the right angle triangle do you know? Opposite over hypotenuse. Can't you calculate the adjacent?
Yeah.
Why is it that you even need adjacent in this problem?
Because of cos.
Cos contains adjacent, only cos. Tan also contains adjacent. So you use your Pythagoras theorem to get your adjacent. Take the values here. Are you getting me right? And then you solve. Please work on it as your assignment. Are you following right? Work on it as your assignment. Chinedu, I will give you a task. You create a WhatsApp poll on it. Are you following right? What I'll do at the end of the class, you meet me, I'll give you the options to use there. Are you following right? So you solve and click on the correct answer. Do you get that right? Solve and click on the what? Correct answer later this evening. He will create a WhatsApp poll. He will create a WhatsApp poll, please. Excuse me. You are disturbing me. If I hear any sound, put off that thing. Please play that. Put off that thing that you're playing. So I'm hearing sound from here. All right, please, let us move on. Okay, let us solve this one again from WAEC. From WAEC. We're going to solve this one together. So this is the question. This is WASEC 2019, question 24. WASEC 2019, question 24. But that is question number what for us? 4. So we have this diagram, very simple question. 52 degrees, 32. Now this question will warrant us to use calculator. It's understandable. You know, WAEC at the time, it's just this set now that there is this, contemplation of possibility of your going on CBT. Are you following right? If you're going for a theory exam, you are allowed to use calculator most generally. Why not? Where are you heading to? Where are you heading to? I return that thing and go home. You are done with your class today. You cannot sit down quietly there and study as you're supposed to do. Return that. You're not meant to take any chair outside from here. If people are discussing, you reduce your voice. You are not meant to play anything. You can't play anything. Those that took the chair out, I don't want to turn my face 2 times before you return that chair. I will expel you. Take note. I don't joke with that. I've already told you guys that you don't come here and misbehave. Those that took the chair out, return the chair now. Save yourself the expulsion. I will expel you if you stress me. Okay, so we have that diagram there. Are you there? And the question says, in triangle XYZ, right, please? In triangle XYZ, written like this, triangle XYZ. In triangle XYZ, comma, xy is xz rather, xz is equal to 32 cm. Angle yxz is equal to 52 degrees. And angle xzy is equal to 90 degrees. Look at this symbol, get used to it. This is symbol of angle. Are you following right? Symbol of angle. This large line you're seeing here means the magnitude, the length. Are you following right? Of the side, xz. So you can see how they are defined here. Xz, is it xz or xy? Let me see the question. It's yz even that was given. Yz is equal to 32 centimeter. Find correct to the nearest centimeter. Find correct to the nearest centimeter. Find correct to the nearest centimeter xz. Find correct to the nearest centimeter xz. You have options given: 31 cm, 25 cm, 20 cm, 13 cm. Are you following right? So we're going to solve this question. It's a right angle triangle problem. Now you're asked to find xz. So identify the side you are looking for. Look at it. Is that not so? Good. Now, if you look at this diagram, what can you say about the triangle? What type of triangle is this?
Right angle triangle.
So you know the names of the side. Is that not so? Which side are you looking for? Which side are you looking for?
Hypotenuse adjacent.
Which side are you looking for?
Adjacent.
Chinedu, you say hypotenuse and adjacent. Was there anything in the question that said you should find hypotenuse? Or do you think you are not to find anything that is findable in the question? You answer what you're asked to find. So without wasting time, please let's go. Now, if you are looking for adjacent, this side given to you, 32 cm, what is the name?
Opposite.
You know opposite, is that not so? Good. Now we can decide to label here as Z, label here as X, and label here as what? 1. Are you following? And then we can attack. This question here, is it Pythagoras theorem that you are meant to use? Is it Pythagoras theorem that you're meant to use here? You said no. Why is it that you can't use Pythagoras theorem here to find y? Because there are two sides you don't know. Are you getting me right? Now I told you can only use Pythagoras theorem when you know two sides and one side is not known. Here there are two things you don't know, so you cannot use Pythagoras theorem. That, of course, is the reason they gave you this angle. Are you getting me right? You have this angle 52. You know the opposite. You are looking for the adjacent. I repeat, you are given the value of an angle. You know the opposite. You are looking for the what? Adjacent. What do you use to solve it? Tan, is that not so? Yes. Remember that on that day I will not be there to decide your formula for you. You should be able to know why is it that at this point I'm using this, I'm using that, I'm using this. That's why I'm taking my time to explain this. See, you know your opposite. You are asked to find adjacent, and you know an angle. You know an angle there. I have to ask yourself is which identity, trig identity, relate opposite and what? Adjacent. Do you have any business with hypotenuse here? Were you asked to calculate hypotenuse? Did they give you the value of hypotenuse? So you don't have any business with hypotenuse. Are you following right? That is why sine cannot be used here. Cos cannot be used here at this point. You have business with tan because you know opposite and you're asked to find adjacent. So it's going to be tan theta equal to opposite. We use x as opposite here, divided by adjacent 1. Substituting, tan theta is tan 52, and then this is going to be, our x is what? Divided by y. So you substitute 32 over y. Remember that that y is our, we have to find what? Xz. That y is actually x what? Z. Of course, when you are done, you know that the y has to be replaced with what? Xz, you know. You are the one that decided to define it as y. Okay, we are moving on. From here, you are looking for y. What do you do? You are looking for y. What do? You cross multiply. So it's going to be y times tan 52 equal to what? 32. But this is a waste of time. I want to show you what you ought to do in example. That is why your basic principles of maths, you don't joke with them. I keep telling students, when a student has a challenge in maths, it's not the topic itself that is challenging the student. It's the basic level of maths. How to add, how to subtract quickly, how to multiply quickly. Are you getting me right? And how to divide. Principles of simple equation. When do you collect like terms? When do you cross multiply? When do you divide both sides by the coefficient of the unknown? Principles of fraction. Are you getting me right? When you have fractions, how do you work out the LCM? I've mentioned 3 key things in what I've just said. 3 key things. 1, the basic operations in mathematics, addition, subtraction, multiplication, and what? Division. They make up one thing. 2, principles of simple equation. When to collect like terms, when to cross multiply, when to divide both sides by the coefficient of the unknown. And 3, principles of fraction. Once a student is very good with these 3 areas I've mentioned, all these things you see here, they are 1 plus 1. Are you following, right? They are 1 plus 1. Okay, let us move on, please. If I cross multiply this, you know that y will be multiplying times 52. Why am I even cross multiplying? Because you are looking for something, and that thing is in fraction form. That is the principle. There is a principle in simple equation that says you're looking for something, if that thing is in fraction form, and you have only single fractions. Are you getting me right? You cross multiply. So on that day of the exam, it's not a day for you to start asking, what do I do here? You don't ask that question. It is today you need to ask, what do I do here? And you're expected to know the principle. You are expected to know the what? Principle. It is just like you coming to our school here, right, at IDK, and then leaving your house. There is this particular road that always leads to IDK. When you get up after preparing, what do? Is it not to follow that road? Is it not to follow that road? Would you not take another direction? If you take another direction, will it lead you to your school? Would it lead you to your school? No. So all these basic principles, they matter a lot. These are the things you really need to learn and learn very well. And these things right from primary school, you start learning them. So we have to cross multiply here, like I said, because what you are looking for is in fraction form. Now, watch the board. If you cross multiply this, must you write it down? Y times 52 equal to 32, just like I did here. You know, I wrote something here before I wiped. Must you write that thing down? The answer is no. Activate your brain. Look at me directly, all of you. Look at me. If you cross multiply this, what would you have we said? Y tan. Now what you're looking for is what? Now, y is multiplying tan. Is that not so? If you are looking for something, and that thing is multiplied by something else, what do? You divide both sides by what is multiplying the unknown. Is that not so? So you see why it says you can allow your brain to go ahead of you. And this is the only way you can actually beat up your time with excellence. It is now you train your brain to go ahead of you. Do you notice that with what I've just said, we are going to omit that step of cross multiplying? Is that not so? Now, if you are to divide both sides, you are dividing by what? Tan 52, which means this goes here and this tan comes down here. So you have y equal to 32 over tan what? 52. Is 52 degrees a special angle? So you have no choice. You must use calculator to evaluate it. This is from WAEC exam. Until now, calculator is being used. Are you following, right? What did you get? 1.2799. Final result or just the time?
Final result. 25. Yes.
Final result is what?
25.
That's what I'm interested in. Imagine you are seated in an exam call where you are allowed to use calculator. You are now pressing this one separately. You are wasting that time. You are doing what I said. You are wasting it. I hope you are following with this. You are following up with this training I'm giving to you. Are you getting me right? You are wasting time. You don't have time in the exam hall. There is one of your WhatsApp, is it status or something? Right of yesterday, I saw something. I think that student is from the art section, and I love that statement. What the person used here is there is no time to look at time. There is no what? You want to look at time. Time is going. So do that thing you're supposed to do. Don't even look at that time. Are you getting me right? And when you are prepared for this exam, you are doing the right thing you're supposed to do. You will not even bother so much about time. See, there are some of you, after I answer one question, your eye will go to the time bar in that system. You answer another one, it will go. That time you are doing like this, you are wasting it. It shows you're not prepared. See, if you are well prepared, which of course you have taken the step, being here, and you are being coached, I'm telling you things you should do, things you should not do. There are some things you should have gone ahead of. Are you getting me right? By the time you apply all of those things, listen, the exam you're preparing for is 2 hours exam, 120 minutes, so there are about 160 questions, right? Apart from English, the other subjects are 40-40. English is 60, right? So 180 questions. If you divide 180 questions by 120 minutes, you have 40 seconds. Are you following, right? Maximum. But I'm telling you that the 40 seconds is even more than enough for so many questions in the exam hall. Are you getting me right? It's more than enough. You are here to be prepared, to be coached, to actually beat up that time. That time is more than enough. Look at this question we are dealing with now. If you know very well the principle of simple equation, are you getting me right? You don't bother yourself here. See this question within 5 seconds, you are done solving it. I must even tell you, if you have this principle as you're here and I'm coaching you, you are learning this, you know the formula, immediately you see this question, you are meant to know that it is time that can solve it. True or false? You are meant to know. That is why you are learning. And because you know that it is time that can solve it, already in a split second, in how many seconds I said? Split, not even up to 1 second. Your brain has processed what the formula is. Tan equal to opposite over adjacent. And with that, you can even make the unknown subject to the formula directly. So even before 5 seconds, your brain has already processed that y is equal to that 32 divided by tan 52. And if it's an exam, you're allowed to use calculator. If you're not allowed to use calculator, like I said, JAMB does not have the right to give you this type of value. Are you getting me right? 52 is not a special angle. If WAEC is to adopt CBT, this set, like they are insisting. Are you following, right? Then, in your objective test, where you're not allowed to use calculator because it might not be allowed. I think when I read their guideline as well, too, they are saying that calculator is not allowed or something like that. They cannot give you this type of value. They'll give you special what? Angles. So you don't need to be scared about that. So you said that everything will give you what, please? You were asked to solve to the nearest what? Centimeter. To the nearest centimeter. So you have 25, and the values are in whole numbers. Are you following, right? And whole numbers. So this is 25 cm. This is 25 cm. So you can see how simple you apply that. Nothing is there. Once a right angle triangle is given to you, and any angle is given inside. Are you following? Any angle is given inside. And you know only one side of the right angle triangle. You should start thinking of SOCA. So we are done with this question. Let us take the next one, which is supposedly the last one. I'd like us to solve this question. After this, I will give you 10 minutes break. After this, I'll give you 10 minutes break. I hope you've copied this assignment, right? You had 10 minutes break. You want to take 30 minutes break. You don't have 30 minutes break today. So we have this question, please. Solve the equation. Question number 5. Solve the equation. Solve the equation cos 2 theta equal to sine 3 theta. Solve the equation cos 2 theta equal to sine 3 theta. This is the question. Oh. This is the question. This is the question. But I want to make the question a bit more complex. This is GMAETS 41. Right? Children, tell them this is GMAETS 41. This is the question you are asked to solve. It is 1 plus 1. We are going to solve it, no argument. And I want to stretch you a bit further to a kind of expound your knowledge. Imagine your examiner gives you this, because the question could have come this way. Let's look at it. Attention on the board. Given, are you with me?
Yes, sir.
Given cos 2 theta equal to sine 3 theta. Evaluate sec, open bracket, 90 minus theta. Evaluate sec 90 minus theta. We go solve that question. We'll do what? We'll go solve it. But don't worry, let's solve this first. Then I'll now take you that step further. I'll now take you what? That step further. You get that right? The only thing is that since I'm the one trying to formulate this last part, I am trying to see how I can target a special angle. And I'd like somebody to do something for me quickly. Somebody should do something for me quickly. Yeah. Do 60 minus 45 will give you 15. Is that not so? 60 minus 45 will give you 15. I want to stress you. I want to stress you more. We'll finish it. I'm not giving that question to, so I want to give you the ideas first. Are you following, right? And I want to get the number that I like you to approach. Okay, so we are dealing with something like sec. So let's say sec. Let me just put you. I wanted to take you to second quadrant. Yeah. Can I? I want to take you to second quadrant. So do this for me. 135 minus 15 will give you what? 120. Right? Good. So, we are going to do this. Let me write it somewhere here. Evaluate sec 135 minus theta. So, we are going to evaluate this after we solve this question. Are you following, right? Now, let us focus on what we have to solve. Are you ready? We are asked to do what? Solve this equation. That is the question from the examiner. Solution. Now, if you give me cos 2 theta to be equal to sine 3 theta, and you ask me to solve it, you ask me to do what? Solve it. Normally, we quote this thing for, we quote it for values of 0 less than theta less than 90. Are you getting me, right? So it goes in the first quadrant. Now, if we are dealing with cos 2 theta equal to sine 3 theta. Remember I gave you the relationship between sine and what? Cos. Sine of an angle is equal to cos of what?
90 minus.
I ask you again. Sine of an angle is equal to cos of what?
90 minus.
Cos of an angle is equal to sine of what?
90 minus.
I hope it's there, right? Good. So all I have to do is change this cos to sine using that part of 90 minus theta. Are you getting me? Or change this sine to what? Cos. So I'm going to write the grammar here. You don't need that. You don't need that grammar. Recall cos theta is equal to sine 90 minus theta, and sine theta is equal to cos 90 minus theta. This is what you use in solving problems like this. So I would like to solve in terms of sine. So I'm removing cos. Are you getting me right? I'm removing what? Cos. I want to solve it in terms of sine. I'll come here now. It implies that, see, this cos 2 theta. The angle in front of the cos here is what? 2 theta. Is that not so? The angle in front of the cos here is 2 theta. It's 2 theta. And since it is 2 theta, you are going to subtract it from 90 if you are converting to sine. Are you following, right? So all you just have to do, in place of this cos, you write sine. Open bracket, then 90 minus what? 2 theta, because 2 theta is the whole angle in front of the cos. I have changed cos of an angle to what? Sine of an angle. Are you getting me right? So that will now be equal to sine 3 what? Theta. So do you see now that this equation is now written in terms of sine all through, right? If you don't want to do that, you can decide to solve in terms of cos. You know, here I'm solving in terms of what? Sine. If you are solving in terms of cos, you will leave this cos the way it is. Are you following, right? Come to this sine, remove this sine, fix cos 90 minus the angle in front. Very simple math now, is that not so? That is the pattern. That is the principle. So you have the idea now. Sine theta is equal to cos 90 minus what? Theta. That's the principle. Or cos theta is equal to sine 90 minus theta. So whatever given to you in front of that sine or cos, you can replace that cos or sine with the other trait identity. Solve in terms of one of them. You know, at this point you have sine. Automatically, what is in front of them must be what? Equal. Is that not so? It implies that 90 minus 2 theta is equal to 3 what? Theta. Okay, is that not true? What we just did is to drop the sign. The some person can just tell you cancel out the signs. Since the signs are equal, cancel them out. But normal interpretation or accurate interpretation to read, the trig functions are the same. Automatically, their argument must be the same. But for clarity purposes, just remove the sign. We say that theta is equal to 90 over 5. Are we correct? Theta is equal to 90 over 5. So some of you are just still processing it now. You have this, I'm telling you, theta is 90 over 5. That is when you start thinking to check. Are you asking me how? That theta? Okay. All right. You see, like I said, we can always allow our brain to go ahead of us. You are an example. At this point, 2 plus 3. You are wasting that time. That's what James for the one is saying. Are you getting me right? Already, you know that this is what you are meant to do. Why not do it? Like, why not get to must you start writing all those? You don't need, please. So theta is equal to 90 over what? 5. And theta is equal to what? 18 degrees. 18 degrees. Now, we'll go back to our question now once you're done with this. Copy, please. Let me now give you what I want us to do. It is not 135 minus 18 that I would like us to do. Not 135 minus 18. Not. I'll give you something else I would like us to evaluate. And the reason I really want to evaluate this, I want to use this opportunity to remind most of you again who were not here when we introduced the concept of special angles. So theta is equal to what? 18. Is that not so? Good. Now you write question number 6. You write question number 6. Any questions? You know, I told you we were going to do something now that I would extend this a bit. So that's that question number 6 now. After that, we take our break. Are we ready? Let's round off this. Let's round off. From question 5, evaluate. From question 5, evaluate. From question 5, evaluate. Oh, my brain is getting angry. My brain is getting angry. I'm trying to do something on the board so that I would throw it at you. Are you there? Okay, evaluate sec. I think we've encountered cot in our problem today, is that not so? We have encountered cosec, is that not so? So you can now see the reason why I want to do it. Sec, evaluate sec. Evaluate sec. I'm wiping here. Evaluate sec 348 minus theta. Evaluate sec 348 minus theta. Evaluate sec 348 minus theta. From question 5, evaluate sec 348 minus what? Theta. So this question we're about to solve now, see, like question number 5, that question 5, that question could have been what they want you to solve. Are you getting me? You could have been given the question in this format. If, or given, are you getting me right? If cos 2 theta is equal to sine 3 theta, evaluate sec 348 minus what? Theta. You see how I presented the question, right? Instead of, okay, solve the equation. This one, they say you should solve the equation. Anytime you hear solve something, it means find the value of the unknown. I hope you know that, right? Solve something is to find the value of what? The unknown. The unknown here is theta. But I'm not saying that what I'm trying to have us do here, the question, the way it can be presented is something like, if or given that, are you following, right? This guy is equal to this. Evaluate sec 348 minus theta. So let us solve it, please. You are meant to do exactly what you did, right? From question 6, theta 5 rather, theta is equal to what? 18 degrees. If the question had been given, say, given that cos 2 theta is equal to sine 3 theta, evaluate sec 348 minus theta. In solving, you will start, your solution will start from here. Are you getting me right? You get your theta, then you evaluate this quantity or this term that you're asked to find. It implies that sec is a very simple thing, though. It's just the presentation from the question that might just shake you. What they are telling you to do is get your theta. Are you getting me right? Then come to this term you are asked to evaluate, fix that theta. You will see what you are going to get. Theta is 18, so you fix your 18. Is that not so? And then solve all this. If you are solving now, this is going to be equal to, remember, this is going to be equal to sec what? Sec what? You are wasting my time. Sec what? So sec 330. So do you see what they are actually asking you to find is sec 330? I'm sorry, but I do not apologize on this. I fired you to the fourth quadrant. I fired you to the what? Fourth quadrant. 348 minus 18 is 330. So everything you use calculator crying out loud. You could just put 18 here and you do what you're doing. You see what I told you? See, listen. The fact that JAMB told you guys not to use calculator, it's not as if they are being wicked. They are really not. I must be honest with you. Apart from types of numbers that might require you using calculator, are you getting me right? Apart from that, there are real mathematics where most of them do not even require you using calculator. In such case, let me tell you something. Somebody that is allowed to use calculator for an exam, and another person is taking the same exam without calculator, but has trained himself within me, right? Using calculator. See, the person will finish the exam and leave. The person done with the exam, leave you inside the exam hall. Because let me tell you something that is disadvantageous about calculator as well too. Sometimes what calculator will give to you, you even start doubting yourself. Does it happen sometimes or not? Yes. Listen, spirit of sitting in the exam is a different thing than you are seated here taking lessons or they give you assignments. See, by the time you press some things in the exam hall, you press equal to, the answer comes out. Your mind might start telling you, are you sure I did not make a mistake in what I input? So why sometimes you that is using calculator, you want to be very careful. Okay, you are pressing 348. You press 3. You look at it 5 times to be sure that it is 3 that you pressed. You go to 4. You want to be very sure. Somebody that is working with this, 348. Like I said, just a basic math. 0 here, 3 here, 3 here. The person is just there. So you, by the time you finish pressing, you want to be sure whether. Please, let's move on. Now, this sec 330 will now convert it to its cos value. Sec is 1 over what? Cos. Sec is 1 over what? Cos. So what you're asked to find here, which gives us sec 330, will now convert it to 1 over what? Cos 330. Are you following? 1 over what? Cos 330. Then you now solve cos 330. You now do what? Solve. All of you drop your calculator. I don't want to catch anybody with calculator. I have a reason why I actually formulated this question in addition to this. I don't want to say it with calculator. If I say it, I will see that calculator. And for the next 2 weeks, you won't see the calculator. Don't be tempted. I have a reason why I decided to attach this question. I don't want to see any one of you with calculator. Can I wipe this? Can I wipe this? Remember that question number 6 we are solving is a continuation of number 5. If the question were to be given that you should evaluate this guy. Are we together? Please pay attention to this thing now. So that if I drop the video lesson, hopefully this weekend, you can follow through. This morning already we have found out that this is 0 degree. Fast. Then back to 360. Is that not so? Good. Is 330 degrees a special angle? Yes. If you want to find out, move from 270. You know that 330 is between 270 and 360. Is that not so? Come to 270, you know what you're adding to get special angles. 30, 15, 15, 30. If you add 30 to 270, what will you get? So 300 will come here. 300 is a special angle. Are you getting me right? Good. Add what next? 15. You get 300 and what? 15. Add what next? 15. You get what? 330. So is 330 a special angle or not? 15. So you don't need calculator. If you are dependent on calculator, then there is a serious problem. Am I communicating? Then there is a serious problem. And look at where the whole thing gets messy. You do not have sine, cos, tan function in that their system in the JAMB. You don't have it. So learn how to obtain these values. 330, that is what we are asked to find. Are you following, right? We come here. Let us assume that the 330, the 330 you measure from 0. Now, is that not so? Yes, sir. Keep coming till you land here, you stop. The angle from here to this point is your 300 and what? 30 degrees. They made me to write it somewhere here, 330 degrees. Now we are going to evaluate the cost of that guy. Are you getting me? We are going to evaluate what? The cost of that guy. One thing you must know first is that in this first quadrant, all the trig functions are positive. Sine is positive here, cos is positive here, and what? Tan also has what? Positive value. They have what? Positive values. If you come to the second quadrant, only sine is positive. It means if you're dealing with sine, like cos and tan value here, your final answer should be what? Negative. If you come to the third quadrant, only tan is positive. If you are evaluating cos and sine in the third quadrant, think of any angle between 180 and 270. Give me 2 of them. Okay, give me 3. Somebody should give me 1 here. an angle between 180 and 270. Think of a number between 180 and 270 now. Yes? So you can see what pressure can do to somebody. Are you getting me? They could not even give me a number between 180 and 270 immediately yet. See, pressure can wipe off your brain if you are not well prepared. I could have solved up to like 30 questions if I want to or whatever, but see, it doesn't help. Understand this thing for what they are. Are you getting me, right? Okay, have you calmed down? 210. 210. Maybe she wants to get a special angle. That is why she was cracking brain. But I was not really interested in special, just any number. 210. If you come here and you have to find tan of 210, your result will be positive. Positive answer. But if you have to find cos of 210, sine of 210 here, the final answer will be minus. Give me a value between 180, okay, let's say between 270 and 360. Here. Between 270 and 360. Here. To what? 359. Very close to 360. If you are to find the value of cos, because in the fourth quadrant here, cos is positive. Only cos is positive. Are you getting me? So if you are evaluating cos of 359 to give you a positive result. If you are evaluating sine of 359, what will it give to you? Tan of 359. Negative. So remember this. I'll tell you something that will help you to remember. All students take cabin. Are you ready to take cabin? Are you ready to take cabin? All students take cabin. If you are moving this way, Acts of Apostles, chapter 7, verse 79. Then you will go and find verse 79 tired. If you are going this way, it is Acts. Are you following, right? In maths, under bearing, you go this way. Are you following, right? But if you are dealing with trigonometry mostly, you go this way. In physics, for you guys in science, you go anti-clockwise. Are you getting me right? It's majorly bearing that goes what? Clockwise, because you measure from the true north. Don't worry, we are going to treat all of those things. We don't enter around. We are in it now. Angles of elevation and depression, sine rule, cosine rule. Are you following? Hero's formula, as the case might be. Area of a triangle. Mention them. This bearing and distance. All of them, they fall under these things we are dealing with. We've just started today. Okay, please, let's move on. Our 330 degrees is measured from here up to this place. Are you following? Yes, and we are to get the value of 1 over cos 330. Now, the first question I want to ask you, the final result of this, will it be positive or negative? Positive. It will be positive because 330 is in which quadrant? And yeah, if you are evaluating cos, you get positive results. So have that in mind. Are you following? Now, how do you get cos of this angle? Secret. You see this first quadrant? You see this first quadrant? What are the special angles in this first quadrant? We are going to count to include both 0 and 90. Are you getting me? Yes, sir. Or you are starting from 0. 30, 45, 60, 90. That's correct. Let me amplify it. 0, 30, 45, 60, 90. You know how to generate them, is that not so? 30, 15, 15, 30. Dear friends, once you know the value of sine, cos, and tan of any special angle in the first quadrant, are you getting me right? You have known the value of sine, cos, and tan of any special angle in any quadrant in this world. Do you understand that? So what is your challenge now? Your challenge is know the value of sine, cos, and tan of all the special angle from 0 to what? 90. Once you know them, don't punish yourself for the other guys. You use them to get the other guys. Are you getting me? Let us not do that for this work. Now, this again will be equal to 1. I don't know the value of cos 330 directly. I will quickly convert it. I'll quickly do what I said. Convert it to an angle in the first quadrant. I'll convert it to what I said. Now, which number helps us to do the conversion? There are 2 numbers which serves as the powerful angle whenever you're dealing with this quadrant. You see all the numbers on this horizontal, because horizontal lines are a real number line. Are you getting me? These angles that you have on this horizontal, they are the ones that help you to do conversion. Are you following, right? They are the ones you use to do what? Conversion. Any angle in the second quadrant, to convert it to an angle in the first quadrant, you subtract it from 180. I'll give you an example. If I say you should find sine 120 now, 120 has entered the second quadrant, is that not so? Subtract it from what? 180. Are you getting it? 180 minus 120 what? So sine 120 is equal to sine what? 60. Do you understand that? If the thing enters the third quadrant, you know the third quadrant, it has crossed 180. Is that not so? What you have to do is that angle in that third quadrant, subtract what? 180 from it. Once you have any angle on this left-hand side, what will be controlling needs to convert it to the first quadrant is 180. Are you getting me right? I'll give you an instance. 240 is a special angle. Are you getting me right? 240 is in the third quadrant already. True or false? What you will do to get the equivalent in the first quadrant is 240 minus 180 will give you. So if I'm evaluating tan 60, for example, tan 240, for example, it will be equal to tan what? 60. Are you following, right? Now, come in here. Remember, you're on the right now, is that not so? You have passed everything that has to do with 180, true or false. 270 does not control. Just for your personal knowledge, until you get to advanced level, you want to know that this line does not exist. You see this vertical line? We call it imaginary line. We call it what? Not for your exam. So save this one in your pancreas. Save it here in your pancreas, so that to give space for other things in your brain. So 90 and 270, they don't control all this angle conversion to the first quadrant. What controls them is 0 and 3 what? 60. Okay, now I want to get cos 360. What I need to do is to convert, cos 330. What I need to do is to convert it to an angle in the first quadrant. And how do you do the conversion? Since the thing is operating close to 360 now, any angle in the fourth quadrant, subtract it from what? 360. So now we are solving cos 330. It is going to be cos 360 minus 330. I hope you all understand, right? Is there anybody that has a question here? Why is it that we are doing this? We are converting this to the first quadrant because it is easy for us to memorize all the values of sine, cos, and tan of angles in the first quadrant. We have a triangle that we use for that. Are you getting me right? Yes. So we proceed in simplifying. This is 1 over cos what? Cos 30. Now, what? Assuming it is not that what I asked you to evaluate is cos. It's what? Cos, COT, which is inverse of tan. Am I communicating? Of this, that. In the fourth quadrant, tan, is it positive or negative? Negative. So if you are doing this conversion, you have to put what? Minus times, because it's going to be 1 over minus tan something. Are you following, right? Because tan is negative in the fourth quadrant. Are we following? Yes. Now we have been able to transform 330 from the fourth quadrant to which quadrant? First quadrant. We cannot evaluate this. I don't need calculator for that. Those that know it, cos 30 is what? Root 3 over what? 2. Most of you are looking like this. Then it's 3 over 2. It's understandable because some of you have not taken the video lesson. But I'll show you how you know that it's 3 over 2. Can I wipe this, guys? Can I wipe this? Now, as I am going to draw this, as we round off our first part of our class, so as to take a break and then come and round off our class today. You see this triangle? If you know grammar, you are on your GMAETS 41 has done practically what he needs to do here. And I encourage you, it is very easy to cram. Whenever you want to memorize something, all you do most times is create a mental picture of that thing. Are you getting me right? As if you are seeing that thing in space. Now there are 2 triangles you need. One goes this way. This triangle is a equilateral triangle. Is what? So each side is 2 units. Each side is what? Here is also 2. But I need you to observe something. I dropped a perpendicular height from here, is that not so? That perpendicular height, we divide these two into what? 1, 1. So you have one here, you have one here. Equilateral triangle, each angle is how many degrees? Remember that the total angle in the triangle must be equal to what? 180. That's what we have discussed, is that not so? And in equilateral triangle, all the angles are equal. Therefore, each angle of this line should be what? 60, 60. So here is 60 degrees, here is 60 degrees. This whole thing here completely is 60. Are you following? But you divided it into how many? 2. So here will be what? 30. Here will be what? 30. In an equilateral triangle, if you drop a perpendicular height, it divides that triangle into 2 right angles. So this is a right angle triangle, this is a right angle triangle. So you can decide to pick one of them and cram. Are you getting me? And memorize. It is from there you can get certain values. Watch. Using Pythagoras theorem, this is your hypotenuse, is that not so? Yes. Here can be opposite or adjacent depending on the angle you are dealing with. Am I communicating? Yes. 2 and what? 1. Can you not calculate this third side? You can using Pythagoras theorem. Are you getting me? Yes. If you calculate it, hypotenuse square, which is 3, equal to this 1 square plus this unknown square. Are you getting me? If you work on it, the perpendicular height will give you root what? So you are meant to memorize this thing. 60 degrees, 30 degrees, root 3, 2, and 1. I just pulled out one of the triangle. Are you getting me right? If I tell you to give me the value, like in this case now, cos 30, you will come here. Cos from what we learned in SOHCAHTOA. Cos is what over what? Cos is what over what? So to evaluate cos 30, once you have this diagram in come to 30. You know, if you are dealing with 30 here, the opposite will not be what? Which number will be the opposite? Which number will be the opposite? 1, is that not so? Your hypotenuse is what? 2, is that not so? Your adjacent is what? Root 3. If it is something about 60 degrees you are looking for, opposite will become what? Is that not so? Adjacent to become what? Hypotenuse. I hope you are following. It's making sense to you. Without this, you cannot solve any question that has angle in your exam hall, though. You can't. That's the truth. I repeat, without this, you cannot solve any question that involves you applying sine, cos, or tan. Are you getting me? Of an angle in exam hall. Now we have this one that is specially for 45. Please, instead of memorizing this, you can just memorize this one. I've picked what you need from here. Look at, are you getting me right? The next one is specially for 45 degrees. Especially for what? It goes this way. 45 degrees. You know, here is 45. Here is also what? 45. Because if you add up these two angles, you get 90. Now this length is 1. This length is 1. The hypotenuse, if you use Pythagoras theorem, you get 2. So these are the two triangles you need to, or right angle triangle you need to memorize to evaluate sine, cos, and tan of values. You understand, right? Okay, let us now conclude this. This will be equal to 1 over cos 30 car adjacent over what? Hypotenuse. Which of these guys will the image appear in your brain in your exam hall? Which of the two? The first one. You locate where 30 is. Remember, you are solving cos, which is car adjacent. What is the adjacent considering this 30? What is the adjacent considering this 30? What is the adjacent considering this 30? Root 3. Those that are saying 1, have you corrected yourself? If you are taking 30, 1 is opposite. Aren't you seeing it? If you are dealing with 30 degrees, 1 is what? Opposite. I hope you are following, right? This is very simple. All you just need is memorize this guy. Then remember your SOHCAHTOA. The side facing the angle you are dealing with is your opposite. So once again, we are dealing with cos what? 30. Cos is adjacent over hypotenuse. What is the adjacent respecting 30 degrees? Over hypotenuse. What's the hypotenuse? So this will be root 3 over 2. Mathematically, these two will go up. I hope you know that, right? The two will go up because the numerator is a whole number. The denominator is a fraction. Keep the numerator 1 exactly like that. Change this division to what? Multiplication. And turn this guy upside down. You inverse. So the two will go up. In conclusion, can I please conclude? Are you there? Therefore, what we are asked to evaluate, sec 348 minus theta is equal to 2 over root 3, or, I've thought you saw, is that not so? Yes. Or, can you not rationalize this guy? Yeah. Anytime you have root sign in the denominator, you are meant to rationalize. In this case, the conjugate of the denominator is what? Root 3. So use the root 3 to multiply the top and bottom. Is that not so? In problems like this, do you use the Omaka CDRL method or you use the general method? General method. Because this is too what? Simple. So what you will do, those that missed the class, multiply on top by root 3 and multiply under by what? Root 3. If you multiply up by root 3, you will get 2 root 3, then divided by, multiply this root 3 under again by what? Root 3. Root 3 times root 3 will give you what? Will give you 3. So this, any one of these is the value of sec 348 minus theta. For this question 5 we solved and extended to question 6. The main thing I want you to learn from these last two questions we solved, how you convert sine to cos in the first quadrant. Is that not so? As a summary, sine theta is cos what? Sine theta is equal to cos what? Cos, then sine cos theta is equal to sine what? Do you think it is necessary for you using calculator for special angles whenever you're evaluating sine, cos, and tan? Is it necessary? No. With this triangle, you don't need that. Then finally, which angles do you need to be able to evaluate sine, cos, and tan of any special angle in this world? Which angles do you need? Audible. The what? First quadrant. So that video lesson I will drop for you guys, I've analyzed all of those things. You know there is no 90 degrees here. Is there any 90 here? No 90. Is there any 0 here? So those ones you can learn them consciously. Although if you take that video lesson, you will see how you got them. Are you following, right? If you are dealing with sine 90, you will get 1. Cos 90 does not exist. What I mean by does not exist is 0. Are you getting me? Sine 90 is what? 1. Okay, let me withdraw that statement. Does not exist. It's actually 0. Sine 90 is 1. Cos 90 will give you 0. Now look at it now. If you go backward, because the sine and the sine and the cos they switch. Are you getting me right? If sine 90 gave you 1 and cos 90 gives you what? 0. Replace that sign with cos now. Are you there? Yes, sir. Cos 90 will give you what? 0. And cos 0 will not give you back what? 1. So please, make sure you take that video lesson. When it appears, plus minus, let's say. In fact, today, I'll just drop it right now. I'll drop it so that I won't forget. And it will help you so that as we go further, when we'll be dealing with sine rule, cosine rule, Hero's formula if necessary, although Hero's formula does not, Hero's formula rather, it doesn't make use of angles for area, so we are not even treating that part. Sine rule, cosine rule, bearing and distance, angles of elevation and depression. Don't stress me. What did I say? Because this is what I'm going to do. Number 1, all the questions we're going to solve, the angles that we're going to deal with will be special angles. Are you getting me? Yes, sir. Number 2, I would not want to see calculator on any table. Henceforth. Are you getting me right? Henceforth, I wouldn't want to. Please take your break. It depends on time. This is already 1:37 here. All right, those in the online space, we are done for today with you friends, okay? Thank you for connecting and enjoy the remaining part of your day.